think it's just lagging. So.
Okay, hi everyone. We're just about to start another exciting tech talk, and Quarkus is the team of the month for sure. Everyone is buzzing about it, and we have this great opportunity to have John Klingen here with us, and he will be talking about how to build Eclipse MicroProfile applications with Quarkus. So without really wasting too much time, I'll just hand it over to John. And John, if you want to take it over and go ahead.
Sure. So I am going to share my screen. Okay, everyone see the screen? Okay, I lost your audio. Don't know if that's me or you.
Yeah.
Okay.
Yeah, it's good. So you can see your screen.
Awesome. Okay, so welcome everyone. Thanks for taking your valuable time out to hear about how to build microprofile apps with Quarkus. And my name is John Klingen. I'm a product manager at Red Hat and also a microprofile committer, one of the co-founders, kind of helped start up microprofile, and my Twitter handle is @jklingen. So you'll see me chat a lot about Quarkus and into microprofile and stuff like that too. So I got a few slides and then an awful lot of live coding. So we'll see how this goes. I'll beg forgiveness now, just in case we run into problems. Okay, let me see here. Okay, going to talk a little bit about the evolution of the Java stack. I suspect many of you are familiar with doing development with Java EE, right? So we've got this stack, this Java stack that's been optimized for most of the last 20 years for basically running Java application servers, right? So the expectation is that you're running on either directly on hardware or in a virtual machine. You're running, you have the an application server running on top of that, running on top of the JDK. The JDK has been optimized for, to a large degree, for running application servers, right? Running lots of, tons of threads, a lot of dynamic activity as you deploy and undeploy applications. And you've got frameworks that have increasingly over time become more and more dynamic. And that means using a lot of reflection, making a lot of decisions at runtime. So where we've kind of been moving over the last 3 or 4 years has been more and more towards microservices. And as you know, Java EE slowed down for a while. Now it's moving to the Eclipse Foundation as Jakarta EE. But while it had slowed down for a while, we basically, as a community, as you know, whether it's vendors or individuals, Java user groups, created the Eclipse MicroProfile, right? And the idea was to continue the idea of creating specifications that foster, multiple implementations, but we do it in a different way than was done with Java EE, and even different from, I think, how Jakarta EE will evolve. And that basically means we treat microprofile a lot like it's an open source community, right? So it's an open source project, I mean. So we have multiple releases per year. We don't necessarily guarantee backwards compatibility, quite like Java EE or even Jakarta EE probably plans to, right? So we consider ourselves a faster moving community to address the needs of microservices development. There's still a lot of movement in this area. So if you look to the right-hand side of this diagram, you'll see that there's a healthy set of specifications. There's a base programming model based on Java EE with CDI, JSON processing and JSON binding, and then JAX-RS. That kind of defines the base programming model. And on top of that, we've got specifications that define how to utilize microservices patterns with a specific set of APIs. And in the market, there's multiple implementations of these APIs. So on the lower left-hand side, what you can see is it's a rather large community, both vendors, organizations, and individuals. A very active community, microprofile.io. And in the lower right-hand side, you see a bunch of implementations. And Quarkus, which I'll be talking about, is also an implementation. We just haven't fully run the microprofile TCKs yet. But there's also multiple specifications in the pipeline, meaning, in fact, one of them is done. We have microprofile reactive streams operators, and there's a reactive messaging spec, context propagation, GraphQL, long-running actions. So there's lots of specifications that are kind of being baked that should come out probably within the next 6 months or so. So we continue to evolve pretty quickly. But again, we're evolving in the context of microservices development, right? Now, what's interesting is if we think about the modern enterprise Java microservices stack, really what we do is we take the same philosophy that we've had, in many cases, the same frameworks that we've had, over the last, 15 years or so, and we just apply them towards microservices. So instead of deploying multiple apps on top of a JVM, what we do is we just deploy a single app, leveraging again many of the same frameworks. There are new frameworks, right? So microprofile is a good example, right? We've got so far 8 or 9 homegrown specs with a bunch more in the pipeline, like I mentioned. So there are some new frameworks, but the way that these frameworks have been evolving is they're still fairly dynamic, right? They make a lot of runtime decisions, and even the runtimes underneath, like an application server, still do a lot of optimizations and decision making at runtime, right? So that's where Quarkus comes in, right? Quarkus basically rethinks this, and it says, well, let's optimize this stack so that we understand that our target environment isn't necessarily running multiple applications on an app server. Right. That is, by the way, monoliths, the Java EE model, that's still a valid model, right? So what we're talking about here is if I'm specifically targeting microservices in a single app stack, that's where we're looking at something like Quarkus, right? Where I can take these applications and these frameworks and build them with the understanding that it's going to be deployed to a Kubernetes Linux container-based environment, and that's kind of those 2 icons that you see under the stack, right? That's kind of the new target environment that organizations are deploying to, and so Quarkus specifically targets Kubernetes and containers. So what that means is, well, in a Kubernetes environment, it's a very it's an immutable environment, right? Meaning that when I develop a container, I tend not to log into the container and make changes, right? What I do is I make my changes in code, and then I run that code through a pipeline, and it redeploys a new container, right? So this is the idea of immutable infrastructure. So if you think about those dynamic frameworks that I've kind of been talking about, where we do lots of reflection, we're making a lot of runtime decisions in deploying to what's really an immutable infrastructure. So Quarkus rethinks that. It says, well, let's not target or let's not make a lot of these decisions at runtime. Let's optimize the frameworks with the understanding that I'm targeting immutable infrastructure. So what we do is we do the optimizations, things like scanning the class path for annotations, pre-compiling the results of that into the jar file if you're going to run on top of Java, or into the native binary if you're going to be running directly on the operating system without a JDK. So we do a lot of this work now at build time with the understanding that we're going to be deploying to immutable infrastructure. So we're basically optimizing that entire stack, right? So you'll see some examples of this. Now Quarkus can run on the JDK. You can put it in production on the JDK if you want to, right? But you can also compile it down to a native binary. And in fact, in development mode, we'll run strictly on top of the JDK. All right, I'm gonna do a quick time check. All right. Now, if I do want to compile down to a binary, we utilize GraalVM to do that. GraalVM is a pretty awesome project for running highly efficient Java code or even dynamic languages that run on top of the JVM. Now, Quarkus doesn't really focus on that aspect of it, on the dynamic language aspect as much, but it does utilize kind of those red boxes that you see in this diagram. The Graal compiler to compile it down to a native code, and we really focus mostly on the Java language, although we do support Kotlin running on top of Quarkus as well. All right, and underlying, even inside of your binary, there's still a virtual machine running, but its role is greatly reduced compared to just running on OpenJDK with a hotspot VM. So what Quarkus utilizes GraalVM for is both native compilation and dead code elimination. So one of the things that we've done with Quarkus is we've optimized a lot of the libraries so that we reduce dependencies both within the library and even across libraries. And what this means is that if your application doesn't use some of the code, it'll be eliminated during the compilation phase. And that means you get a relatively small executable binary. Right. Okay, so let's do a little bit of live coding. Okay, so can everyone see? Let's see here. I'm going to make this bigger. I do have the chat open in another monitor, so if folks want to ask questions or make comments about being able to see the code I write and stuff, just let me know. All right, so. To create a project with Quarkus, what we're going to do is we're going to use the Quarkus Maven plugin. So this will actually generate the outline of a very simple RESTful endpoint. We are working on kind of a web-based starter as well, but for now, what we're going to be using is the Maven plugin to generate the source code. So what you can see here is I'm just providing the Maven artifact information that I want to be generated for this, right? For this project, right? What the group ID is, the artifact ID, I'm going to call it person. We're going to create a RESTful resource called person resource, and it'll be listening at the person endpoint, right? So I'm going to go ahead and create this. All right. So if I want to take a look at the source code real quickly. What you see is it is, kind of like what I said, it's a very simple RESTful endpoint. Now, let's add some additional Maven dependencies so that we can build out an actual microprofile application. So Quarkus, again, with the Maven plugin, has a goal called list extensions. An extension in Quarkus is basically what I mentioned. It's a pre-optimized framework that, well, it's optimized for efficiency, like I mentioned before, but it's also, you can assume that if it's in a Quarkus extension, it could also be compiled down to a native binary. Not all the frameworks out in the Java ecosystem can be compiled down to a native binary without some extra work, and we've kind of done that extra work on behalf of the developer for these frameworks. So if we take a look at the extensions, we've got Arc is our CDI implementation for Quarkus. You see we got some Camel extensions, Flyway, and other database-related extensions, Hibernate, some JDBC drivers. Let's see what else we have. Infinispan support as a client. JSON, consuming and producing JSON via JSON binding and processing, Keycloak for security, Kubernetes. I hope to have time to show that one. It generates the YAML that enables you to take your application and deploy it into a Kubernetes environment. Kotlin I mentioned. Let's see, you got transactions. All these small write ones are basically microprofile spec implementations. Right, so you can see context propagation, fault tolerance, health, metrics, a lot of those are implemented in the SmallRye project, and Kafka support and all that. All right, so that's quite a big list. So what I'm going to do now is, and here, is show you how to add some extensions to our project. So what we're going to do is use the add extension goal, and we're going to specify the extensions. Oops, if I could spell properly. All right, so one of the nice things about this extension is you don't have to necessarily type in the entire strings that you see here. You can just type in a subset, and if it can find without any kind of name collision, it'll add it. Right. So let's do kube. I mentioned that for doing Kubernetes YAML generation, fault tolerance. Let's use the MicroProfile REST client. We're going to show that. We're going to show some metrics. We're going to show Open API and Swagger. This one I'm going to type out because we will hit a namespace collision. Quarkus, REST easy, JSON binding. Let's see, we're going to do Panache. Panache is a layer, an ease of use layer on top of JPA and Hibernate. So that'll be interesting to show. Going to show, let's see, we're going to use the H2 database while we're developing locally. So that we'll use in-memory database. But when we go into production on our Kubernetes cluster, which I have running on my laptop, we'll use Postgres, and we'll use MicroProfile health check. We'll see how much of this we can actually get to during this hour or so. Now this is going to fail because we actually ran into a namespace collision. I mentioned Postgres, but there's actually two different Postgres database drivers. One for using the async reactive driver, the other one for using a standard JDBC driver. So what I'm going to do is choose the standard JDBC one, and we'll fix that. Okay, so that was added. Now I'm going to do one other kind of little bit of pre-optimization here in this for this project, and I'm going to set an environmental variable. So I'm going to set Quarkus _ profile equals dev. So this is going to come in handy when we start using microprofile config, where we can have different configuration profiles, one for development and one for production. All right, now I'm going to open this all up into Visual Studio Code. Of course, you can use your favorite IDE. Again, let's take a look at the PALM file. And you'll see we're using version 17 of Quarkus. This is the most recent version. And you can see all these Maven dependencies that we just added with add extension. Okay. And there's also, if we want to compile down to native code, one of the things you'll see is a Maven profile called native, and that'll let us generate a native binary. I'm going to try and minimize that because it takes a while, and we don't have a lot of time to show an awful lot of functionality. So I'm going to create a terminal. Now what I'm going to do is put Quarkus in development mode. Actually, I should have set the profile here. So in fact, let me do that in this terminal window. Now I'm going to run Quarkus in developer mode so I can develop this project, Maven Quarkus :dev. So what this is going to do is it's going to open up a debugging endpoint if I want to do debugging. I don't think I'm going to show that here, again, because of time. And then it actually runs the app. Now, let's see here. I am going to pull over another window. And we're going to go to localhost :8080/swagger UI. So MicroProfile has open API support, and that's what's kind of underlying this endpoint. Quarkus supports an embedded Swagger user interface, so you can try out the RESTful endpoints that you create. In this case, it's a simple hello world. Oops, actually, I want to extend that. So let's actually try out the RESTful endpoint. I may have to make this bigger. Okay, and we're going to execute the endpoint, and you'll see that it responds with hello. Now, I'm not going to be using the browser to interact with the application because I don't want to have to constantly switch back and forth between the browser and the application. So I'm going to do most of the work directly in the IDE in a terminal. Okay, so so you can kind of checkbox off the fact that MicroProfile supports Open API out of the box. So I'm going to go back to actually the presentation here. Go full screen. And talk a little bit about MicroProfile config. Good microservices development style, kind of a 12-factor app is you want to externalize your application configuration. And you could do that with MicroProfile config, where you can inject the value of a property into your application. And behind the scenes, there's multiple property sources, config sources, right? So you can specify a property using a Java property on the command line, or you could set an environmental variable, that's the middle box on the bottom, or you can define it in a microprofile-config.properties file. Now what Quarkus does, it does support that microprofile config properties file, but it also supports an application.properties file, and that's the one I'll be using during this presentation. And you could also create custom config sources. So you could create a config source for Vault, for Eureka, whatever, right? There's other config sources out there. In fact, there's a MicroProfile extensions project that actually extends a lot of these capabilities of MicroProfile. So GitHub, I think it's at github.com/microprofile-extensions project. All right, so let's go back and do a little bit of coding. So I am going to bring up, oops, not test, main Java person resource. Here we go. So this is the code that was generated. Now what we're going to do is add in the ability to inject resources from an external location. All right, so let's do @inject. Config property, this is a MicroProfile API. Let's make sure we choose the right one. Oops, let's see, what is it here? We want to do name is going to be greeting. And we're also going to give it a default value, just so we can test it out right now. And the default value is going to be hello. Okay, and we're going to inject this into a string variable, greeting. But down here, we're just going to return greeting. All right, so let's go back to, I have to create a new terminal window. And I'm just going to use the HTTP IE kind of command line tool. So you just type HTTP and then the URL that you want to access. So we're going to do HTTP localhost :8080/person. All right, and you see we got hello. Now, what you may not have noticed is that I didn't have to compile anything. I didn't have to hit Control-C, recompile, and then restart the app, right? So Quarkus is actually live loading all the changes that I'm making as I make them, right? And it does it not just for code, but also for properties in the property file. So let's go ahead and do that. Oops, here we go, application.properties. So what we're going to do here is we're going to add a greeting. And here, let's see, we want to call it Hola. Okay. Okay, yeah, I'll do Hola. There we go. And let's hit the endpoint again. And what we'll see is actually picked it up out of the property file. So there's an order of precedence with MicroProfile, right? Where it'll look at the config file first and pull it out of there. You can override that by using an environmental variable, and you can override both of those if you use a Java system property, right? By -d greeting. Okay, so that's pretty cool. Now let's take a look at another API, the MicroProfile REST client. So with JAX-RS, building out a REST API takes a little bit of work. It uses a builder pattern. to interact with a RESTful service. With the MicroProfile REST client, what it does is it takes a very type-safe approach to doing development of a RESTful client. So for interacting with a RESTful service, really you're just manipulating a Java object, right? So let's go ahead and build out a RESTful client. So go back to our code. And what's also nice about the RESTful client is it gets rid of some of the boilerplate. So I'm going to go find our project here. Oh, I moved a file on accident. I'm going to just delete that. Earlier when I was scrolling up, I accidentally copied a file. All right, here we go. Let's go back here. And now we're going to create a new file. We're going to call this the hello REST client.java. All right. And we're going to have a package. And what we're going to do is create an interface. Interface hello REST client. Now we have to annotate this interface with a couple of things. The first is register REST client. Okay, and that's going to register this this RESTful client so that we can actually inject it in our actual application code. So next thing we're going to do is add path. So which endpoint is this going to access? Slash. And what is the remote service? What does the remote services method signature look like from a method and the HTTP endpoint look like? So we're going to use get, and we're going to produces a media type. Oop, that's not what I wanted. That was bad auto completion there. Media type dot text plain. Okay, and the method is just going to be public string hello. So basically in my, we got to fix our imports. And we want the JAX-RS produces. There we go. So what this is, whenever I invoke this this endpoint, invoke this method, it's going to call the RESTful endpoint. But one of the things we need to do is point to the URL where the actual endpoint is. So I can either specify that, I think here, or I can specify it in the property file. And so what I'm going to do is specify this in the property file. All right, so I'm going to go back to, actually, I have to show something slightly different first. I was going to go back to the command line, but instead I'm going to show you the fact that I've already got a hello service running. So basically, I have to start it. The hello service is the code that was basically generated when I generated this project at first, right? It just responds hello or with some other message. So what I did is I took that and I actually compiled it down to a native binary and deployed it to Kubernetes. And if you take a look here real quick, what you'll see, if I look at the actual log, you'll see that this actually started in 39 milliseconds, right? Which is actually kind of slow. Normally this starts in like 10 milliseconds. But I have lots of things going on right now on the machine. So that's pretty impressive for a Java application, right? All right, so what I need is the endpoint. All right, so now I'm going to go back to my source code. I'm going to open up the property file. And I'm going to paste this in while I can. Now what I have to do is provide the property that the MicroProfile REST client will read. And there's a specific pattern for that. The pattern basically starts with the name of the package. So I'm going to copy that because it's convenient. Dot the name of the class, hello REST client, followed by MP REST, followed by the URL. Okay, so this is going to be the endpoint, and I think I need also have to add hello. So MicroProfile REST client will read this property and figure out this is the endpoint I need to access and do the Java binding, Java object binding if I need to. Okay, so save that. Let's go back to our client. Now here we have to inject the RESTful client, right? So at inject, now we're going to do at REST client. Okay, and we are going to then have our hello REST client. I'll call it hello client. All right. Sorry, got a few different things going on in the background. I'm trying to stop. Okay. Now this should actually inject our hello client proxy directly into the hello client variable, and then invoke. When I actually invoke the hello method, it'll actually make the remote call. So what I'm going to do here is do hello client dot hello, right? So let's cross our fingers and make sure this actually works. And it did. So it's calling howdy, which is the message that's actually predefined in the hello service running in the Kubernetes runtime, right? Which is OpenShift. Okay. So let's head over back to our slides if we can. Now, what's nice is, again, you didn't see me recompile. All I had to do was save. Didn't have to rebuild, recompile, restart. A very nice natural flow towards doing development. Now, since we're making a remote call, we're going to add some fault tolerance support into our application. So how do we deal with failure if the hello service happens to be down? So in fact, let's even do that. Let's actually no, I'll do that in a second. So what strategies do we have to deal with fault tolerance? Well, I can use the asynchronous annotation and run a method call in a different thread. I can use a bulkhead that basically limits the number of concurrent accesses to a resource so that you're not going to overload it. Circuit breaking, a lot of you probably understand what that is, but basically lets you fail fast. And it'll occasionally check the remote service to see if it's up. And if it's up, then it will call it. And if it's not, it'll potentially do a fallback. And that's the next annotation. So if you're making a method call and that method happens to fail, you can provide alternative logic with the at fallback annotation. I'll be showing that one. If you happen to have a failure, you can also use retry logic with the at retry annotation. Some might think that's an anti-pattern, but if you have an unstable network, it could actually come in kind of handy. And then the last one is a timeout. If you want to make sure that you provide a responsive response back to your client, you can limit the amount of time your remote call might make. So you can set it though it'll throw a timeout exception if it exceeds some threshold. So what I'm going to do here is we're going to take this call. In fact, I think at this point I can just get rid of the endpoint with it being a JAX-RS endpoint and just simply make it a method call. And what we're going to do is we're going to basically make this a timeout. And after a certain period of time, if we don't get a response, then it's going to return with a timeout exception. Okay, and let's see here. I think I need to import that. And now there's two parameters I can provide. One is the unit. So unit of time, I'll just leave it at the default, which is milliseconds. And it's also going to, by default, take 1 second, 1,000 milliseconds. But we'll just make this shorter. We'll say, oops, what was it? Value equals a half a millisecond, right? So it's going to time out after a half a millisecond. We're also going to provide a fallback method. So if this method fails because of some exception, then what we're going to do is provide some fallback logic. So what we're going to do is specify a fallback method. We're going to call it hello fallback. Okay. Now what I have to do is provide the fallback method. Oops, sorry about that. Go down here and say public. And the fallback method just has to have the same method signature as the method that the fallback annotation is on. So public string, we're going to call it hello fallback. And it has to return a string. All right, so we're going to return a Mrs. Doubtfire. Hello. There we go. So I am now going to rerun this application. And oops, hold on a second here. I forgot to do something. Let me switch gears here real quick. I'm going to add a little bit of JPA logic first. Like, actually, do I want to do it that way? This is the problem with live coding. There's so many different paths you can take. Actually, no, we'll just do it this way, I guess. So, I took the endpoint off. So let's just do it this way here real quick. We'll add it back in. At get and at path. There we go. Oh, no, just at get is all I think we need. Okay, so now it's calling hello. Okay, I went out of order here a little bit of what I was intending to do. So I'm going to go back and go back in order. So first, we're going to do a JPA entity using Panache, and then we're actually going to rely on the fallback method. So let's actually go ahead and create a new file. We're going to call this person.java. All right, so with person, we're going to make it a JPA entity. And with a JPA entity, it's basically an annotated Java bean, right, in a lot of ways. But what we're going to do is we're going to use something called Panache. And to use Panache, we're going to extend Panache entity. And for some reason, I am not getting auto completion on that. So let me go back to my POM. Do I have Panache in here? Yes, I do. Hold on. Entity. Let me try that. There we go. That would be nice. That was the problem. And we are going to import the JPA entity. All right, now I get some really nice things with Panache. Typically, you would have to create private fields with getters and setters, but with Panache, you can just make them public fields. So we're going to say public string name and public int age, right? And I can annotate these with JPA annotations like, at column, I can put in hibernate validator constraints and so on. In the interest of time, I am not going to do that. But at this point, this is basically a JPA entity. Now what we're going to do is go back to our code and let's provide a new method, get, and at path, we'll say list all. We're going to list all the entities in the database, and we are going to produce. Oops, I think I imported the wrong one. No, it produces. That's the wrong one. All right, sorry. At produces. Where are we at here? JAX-RS version of that. Okay, media type dot, we're going to return a JSON. Application JSON. And why am I getting application? Do I have the right media type? No, I don't. For some reason, I'm having a hard time today importing the right packages. Okay, let's start over here. Come on, media type. And we want the JAX-RS version of that, .json. Okay, finally. Turn that. Now we're going to return the list of all the persons in the database. So we're going to return, let's see, public list of person, list all. And now, because we don't have a named query, we're going to use a nice convenience method in the Panache base class called person dot find all. Right? Is that find all? There we go. And return that as a list of entities. Now we got to fix our imports. Public list must return. Oh, I haven't returned it. That would be nice. Now let's try and actually hit the endpoint. List all, and it's going to fail because we haven't defined our application properties for the JPA data source. So what I'm going to do, this is where I'm going to do a little bit of cheating. I'm going to copy and paste. All right. So what I've got now is a development, in development mode, I'm going to talk to the H2 in-memory database, and in production, we're going to talk to Postgres. Now, this is where that profile comes in. So with Quarkus, if you have an environmental variable or a property set called Quarkus_profile, it'll actually then utilize that profile name here and select the properties with that profile name, right? So I specified dev as the profile, right? So I prefix this, these with the dev profile. Now let's go ahead and try this. And I'm still running into errors. Let's see here. No database driver is specified. Did I not? Hold on. Dev. Make sure I set my my profile correctly. Okay, and still having problems because it's. I wonder if I have the H2 database driver in my POM. This is the live coding. The problem with live coding. Oh, H2 is there right here. Now you're all probably screaming at me right now saying you forgot something. No dialect driver specified by Quarkus.database.datasource.driver. Okay, let's go back. Oh, I didn't save the file. I think that was it actually. Okay, that didn't work either. This is actually quite embarrassing. Okay, I saved the property file, go back to the person list. That should work. Why is that not working? Oh, person table, the table person is not found. So that means I forgot to do something here. I forgot to basically set drop and create. So there was no database table, so we have to drop and create the database table. That's what the problem is. All right, so there we go. Now it worked. Sorry about that. But the nice thing is, I'm running into all these problems because of my poor coding style, but I'm never having to restart, right? So I guess you might say that I'm actually failing fast. So now we're talking to a database. Let's do one other thing with the database. Let's make sure that we can add a person, right? So now we're going to use at post. We're going to do a produces and consumes of a JSON data type. And we're going to public person. So we're going to return the person that we're adding. Add person. We're going to be adding a person. Now, the way that you add with Panache, again, there's no named query. There's no entity manager involved directly in the code that you write. What we're just going to do is we're just going to call a person.persist method. We're inheriting that from the parent class, right? And then we're going to return that same person. So that's pretty cool. All right, I'm going to save this code. And now what I'm going to try and do is actually add a person. Method post is not provided. Okay, running into another error. Get. Oh, I forgot to add something at transactional. This has to be done in the context of a transaction because we're updating the database. And I think that might be my problem. There we go. So you'll notice that there's actually an ID being created for me. So Panache actually provides automatic ID generation out of the box. If you want to use your own strategy, Panache supports that as well. Right? Okay, so with all of this in mind, what we're going to do is go back to our code, and we're going to add one more method. Here we're going to say at get. This time we're going to get a specific person. So we're going to specify the ID, and we are going to, let's see, public. Let's see, we're going to make it return a string, get person at path param. So we have to, path param ID, long ID. Here we go. So what we're going to do is then find the person, to do a lookup by ID, it's actually really easy with Panache. We just say person.find by ID, and we're going to pass in the ID. And we're going to return something here. So what we're going to return is a string, but we're going to kind of build this string from scratch. So we're going to call the hello method. So we're going to greet this person, plus add this person's name, person.name, plus, remember it's a public property. But if they were a getter, it would call the getter. So that's a really nice feature. Okay, oops. You are person.age plus years old. Okay, so that works. Now what you're going to find is if we actually try to list all the people, they're going to be gone. That's because what Panache is really doing under the scenes is it's dropping the class loader and basically reloading the entire application from scratch. So anything that's in memory is lost unless you persist it somewhere like a database, right? So what I'm going to do is I'm going to actually post these people back, create these people again. Now if I actually want to go and just list that one person, what you'll see is it's saying, howdy, Duke, you are 25 years old, right? So now if we go back to our fallback logic, right, what we want to do then is basically do a fallback if there's a problem with making this remote call to person. So I'm looking for our, here we go, for our hello call, right? So what happens if this fails? Well, let's find out. So I am going to go back to OpenShift, kill all copies, all instances of this application. So now we have nothing running. So hopefully this time it will actually call the fallback logic, which it does. Hello. So that's pretty cool. All right. So what if we want to do some additional logic around counting how many times this method fails, and then being able to view that in a Grafana dashboard, for instance, right? So if we go back to our presentation, MicroProfile also has, let's see where we at here, MicroProfile metrics. So with MicroProfile metrics, I can actually create custom metrics in my application. And this gives you an idea of some of the metrics that are available. What I'm going to use is that counter. Some of this is changed with MicroProfile metrics 2.0, but right now we're using MicroProfile metrics 1.1. Right? But what you get out of the box with metrics is an endpoint slash metrics that can be polled by, for example, Prometheus. Right? And with that, you get some base metrics that are required by MicroProfile, things like CPUs and memory available, some vendor-specific metrics if a vendor wants to provide that, and then of course your application metrics. Right. So let's actually try and add a metric in here. So what I'm going to do is, let's see here, come back here. We're going to track a metric. We're going to say at inject a metric, and we're going to give this metric a name of hello fail. The number of times the hello method fails, and we're going to make this a counter. Okay, so let's do a little bit of auto importing. There we go. Now every time the method fails, so let me see if we can find the hello, we're going to increment the counter. So I'm going to say counter.increment. Right? Okay, so let's add a couple more people. Because remember, we reloaded. So we're going to add our people again. Now what I'm going to do is hit the metrics endpoint. Let's see, metrics. So this is in Prometheus format by default, but you can see there's some vendor-specific metrics. There's some base metrics that are required by MicroProfile. And now what I'm going to do is, let's see if I can do a grep. I'm going to look for our application metric. And there you can see, let's see, so far it says it's failed 0 times. So let's try this again. It should fall back whenever we get this person. Let's see, hello. Now let's go back and count it again, and you'll see that it's failed 3 times. Right, so now I can keep track of application metrics and create a Grafana dashboard running inside of Kubernetes and everything. So I think maybe at this point, we got a few minutes left. I don't know if I'm going to have time to compile this down to a native binary. Well, maybe I'll try. But I have to do one thing first. I'm going to change the endpoint here. Because when we're running in, I forgot to make this as a part of the profiles. So we are going to do :8080/hello. When we're running in inside of Kubernetes, the URL for the service is going to be different because we're not going through an external gateway, an external proxy. So there we go. So I'm going to try and compile this down to a binary, and we should be utilizing these database properties when we do that. So first thing I'm going to do, maybe I'll do it right now before I forget, is I am going to modify my Docker file to make sure that I'm specifying env the right profile equals prod. There we go. And we're going to compile it down to a native binary by specifying native, but we want it to be in a Linux container. So we got to compile it into a Linux binary, right? So that's what this line right here is. It basically says build it as a Docker image, which is going to be a Linux binary. Right? This is going to take maybe more time than we have left, but we're going to give it a shot. Tanya, I'm not sure how we handle Q&A.
So far, it seems that you're doing just a perfect job. So questions so far.
Anyone have questions around MicroProfile or Quarkus, please enter them into the chat. And I apologize for having some technical difficulties along the way. Normally my live coding goes a little bit better than that.
I'm also hoping the sound came across really well, because I was having problems on my end, but I think it's a problem in our office.
Okay, I'm double checking my cable modem and it looks to be okay. Okay, while it builds, let's see here. Maybe what I'll do is show you a little bit about getting started with Quarkus. If you want to get started with Quarkus, go to quarkus.io. There's literally a get started page where it will take you through some of the steps that I've showed you here about creating your first application that use the Maven plugin to create a project, kind of like you saw me do here. How to build a native image. How to use Maven and Gradle. Gradle is also supported with Quarkus. There's actually, I'll go to extensions first. There are many extensions, like I mentioned, that cover all sorts of functionality that you can use with Quarkus. If you're running in JVM mode, you can pretty much use any Java library that you want. The issue is if you want to compile down to a native binary, then you might run into some issues, right? Where you'll have to use Quarkus extensions or do a little bit of extra work, or work with the framework provider to kind of support native development. There's guides for all of this functionality with Quarkus. There's a guide on that specific functionality. If you have code within your organization or your own custom frameworks, we have a guide that kind of explains to you, well, if it doesn't compile down to a native binary out of the box, then you can create your own extension, so that your framework providers within your organization can make them an extension that other folks can use, right? So we've got guides on doing database manipulation. There's a Mongo extension being worked on right now. All sorts of web style extensions. Some of them I showed you. Messaging with Kafka, and reactive messaging with MicroProfile reactive messaging. Some security extensions. So there's actually quite a bit there. I thought we had some camel guides here too. Let's see how our compilation is doing. Oops, we're this way. And it's still building. Yeah, I don't think it's going to build in time. So it takes about 5 minutes. But one thing I did do, and you might find this kind of interesting, is I kind of pre-ran this in another OpenShift project, right? So if we go to kind of my backup project, you'll see that I have this running. I have the person project running. And what's really cool is because Quarkus is so efficient, I can just run just a ton of copies of this. I'll just do 30 for now here. For the database, I'll go and I'll create maybe 6 copies. What I've actually done, I did this yesterday, kind of testing the limits of what I could do with this on my machine. And I had 200 copies of Hello running as a natively compiled Java application, along with 25 copies of the person project. So you can see it scaling up, right? So it's actually starting these natively compiled Java applications like super fast, right? And then I've got about half the CPUs allocated to this virtual machine. So it's actually pretty cool. And I guess with that, we're at the top of the hour. I apologize for some of the technical difficulties I ran into. I didn't get to show you MicroProfile health checks. And so with MicroProfile health checks, there's the ability to kind of expose the health, the liveness and readiness of your application to your to the environment, in this case Kubernetes, so that if it sees that it's not live, it'll kill the pod and restart it, right? Or if the pod isn't ready, it won't direct traffic to it. So that's a quick summary of microprofile health. Again, sorry for the technical difficulties. No matter how many times you practice this, and trust me, I did, there always seems to be issues. Tanya, I don't know if there's any closing verbiage that you wanted to add. All right, well, I think we are actually done here. I think we seem to have lost Tanya. And I think we're still recording. All right. Well, anyway, thanks everyone for joining. I apologize. You can find me on at jklingen on Twitter. And although I'm kind of embarrassed with some of the problems I ran into. So just be nice. All right. Thanks. Bye.